And welcome back to another video to this series. I'm going to solve the token challenge today, so let's jump right in. So the goal of this level is to hack the basic token contract below. You're given 20 tokens to start with, and you'll beat this level if you somehow manage to get your hands on additional tokens, and preferably a very large amount of tokens. Let's say the contract itself. So we have a contract token, we have a balances mapping which just says this address holds this amount of tokens. This is the total supply. Upon deployment of this contract, you pass in the initial supply, which is given to the total supply. This initial supply is basically how many tokens you want to have, and the person who deploys the contract will have all the tokens to start. We have a balance of helper function that just reads the balance of specified address. That's what it does. So everything looks so good here and here. So the bug must be in this transfer function, which it is. So what does the transfer function do? So it transfers to some address this amount of tokens, and for it to succeed, to return true, it needs to pass this condition, which says that the balance of the sender minus the value, the amount he wants to send, needs to be greater than 0, of course. The job of this condition is to check if the message that sender has the amount he wants to send. And notice here, very important thing, we are working with Solidity version that is less than 0.8.0, which means this contract is vulnerable to overflow and underflow attacks, because Solidity in this version doesn't check, in each mathematical operation doesn't check for overflow and underflow errors. They can happen, they can occur, and they would just, the transaction wouldn't revert like it would if you were using 0.8 version or any version above. So what happens here, we have this check, we are making sure that he has the correct amount. Then what we do is, of course, we'll subtract the amount he wants to send from his balance and just add it to the recipient. Then we return true. So what you need to understand here, first of all, when we say uint, by default, when we say uint, we are saying uint 256. And uint 256 means that this value can store values in the range of 0 to up until to the number 2 to the power of 256. And this is a very large number, and this is why I have developed a simpler contract that uses uint 8. But let me first clarify what does uint 256 means. 256 is the amount of bits, not bytes, the amount of bits you can store in this variable. This is basically the amount of memory you have available. And also the uint8, as you can imagine, can store values from 0 up until 2 to the power of 8, to this number, 2 to the power of 8, which is 256. So we can store a value like 200, 255, but we cannot store 256 actually, because we store the 0 value. We have 256 numbers. Since we store the 0, we'll store up until 255. 255 is the largest number we can store in this value. Also, another thing to note here is that uint stands for unsigned integer. Unsigned means there is no sign, which means it only stores positive numbers. It cannot hold negative numbers. Where I'm going with this, so you can see in this check we are performing a subtraction between uint, one uint, and how do you know this is a uint? Well, the balances mapping, as you can see, stores uints, and this value is also a uint. So a subtraction between two uint numbers is always going to result in a uint itself. So a uint is always greater than or equal to 0. So this is a redundant check. So it doesn't accomplish anything, and because it will always be true. This is the first bug we have, but this is not going to send us token, and it's not going to solve the challenge. This is the second line of code when you have a bug. And what happens here is We take your balance, which is 20, if I run this function with my address. We subtract the value. So we can pass in anything we want here. I have 20 as my balance, and let's say I pass in 21. So 20 minus 21 is a negative number, it's minus 1. But since we cannot store negative numbers, we'll just hold the maximum number, the maximum value a uint 256 can store. And this is where we'll get a large amount of tokens, as this text suggests. To simplify this, you know how much I like to be practical and show you instead of just learn some theory. So I have developed this contract which stores a number, uint 8 number. It stores the largest number, 255, and we can confirm that if I click on number 255. And what happens if I add 1 to this number? This function just adds 1. So if I click on add 1, the number will start from 0 once again. Instead of 256, it starts from 0, because you can imagine all the variables being in a circle. When we have 255, we just jump to 0 because we cannot go anywhere else. So this is an example of overflow, and what I'm doing here, I'm using this first address in Remix to give myself 20 tokens, just like we did in the level. And by the way, I'm showing you this just because I think it's an easier example to understand than the level. That's why I'm showing you this. If you understand this, you will be able to solve the level. So I'm giving myself 20 tokens, and again I have a balance. This time is public because I want to see the balance here, and we can confirm that my balance is 20 if I copy the address, go into the balances, paste it, and you can see it's 20. We can go to the second address, copy this, and check out its balance. It's currently 0 because we haven't assigned it any tokens. Transfer function, what I'm doing is I'm performing the same check, which is redundant, and I'm also to the second address. As you can see, these two are different. To the second address, I'm just saying this address should have the balance of the message.sender, which will be this address, which is 20, minus the value, which is going to be 21. So let's see what happens if we perform this function. So let's choose the first address. This is has 20 tokens. Let's go transfer. Let's choose 21 as the value, 20 minus 21, and see what we get. So the transaction is successful. Let's now copy this address that I modified the balance to, paste it here into the balance, and as you can see we have 255 instead of 20 minus 21. So what happens if I perform 20 minus 22? Let's click on transfer, check the balance, and now it's 233. If we do that once again, it's 211. As you can see, it gets the largest number. It starts from the maximum value and it subtracts from there instead of having a negative number. And how can we solve the challenge finally? You can open the console, and all you have to do is say contract the transfer, and you need to pass in an address first. It doesn't really matter this address that you pass in, and then you have to say 21. This address can be any random address like this one. So, and once you perform this, you should check the balance that you have. So before this function finishes, it actually finished. So let's check our balance now using the balance of function, and we'll await this transaction to finish. And as you can see, it is a very large number. It cannot even store the number in one variable, so I think it does that with multiple numbers. That's what happens here. And previously, if we were to check out the balance of our address, it would have said just 20. But now we have the maximum int value, integer value basically, amount of tokens in our account. And this is basically how you solve the challenge. Now if you want to check if this is correct, you just click on submit the instance, confirm the transaction, and you've completed the level.